going to be doing is learning how to calculate the change in position. Now, change in position involves positions, and we've already talked about that. And so what we're going to be looking at today is how we can actually do a calculation based on starting position and final position. Now, one of the things that you already know is you've already been able to identify the starting position. And the symbol that we use for starting position is XI, or initial position. Now, when you take a look at your graph, your XI is simply your y-intercept on your position time graph. So that position right there, which is 200, is going to be my starting position. So in this case, my XI is 200. Now, you've also used data tables with the Bubble Lab, and we can just simply look at a data table and say, what is my starting position on the data table? And naturally, you see at time 0, my position is 5 centimeters. So my XI in this case is going to be 5 centimeters. Now, that's not new. That's just repeating what we've already done. The ending position is going to be your XF. So if you look at the symbol for that, XF would be final position. And if I look here on my graph, my final position is about 500. That would be my XF. And my unit is going to be in meters. We put meters down here as well. And my final position here is going to be 3. My XF is 3. And my unit is centimeters. Now, these are just discrete data points. To calculate the change in position, you'll notice that there's an arrow over the top of it, and what you do is you take the final position and you subtract the initial position or starting position. Now, the order of that absolutely matters. XF minus XI. If you flip the order, then you're not going to get the correct information. So if you take a look at this formula, delta X simply means change in. Okay, so delta X, my final position based on my graph was 500 meters. My initial position was 200 meters. The math is simple. We end up with 300 meters. Now, you'll notice there's actually 2 things that this tells me. Remember that if an arrow is over the top of any value, it's a vector, meaning it has a size and a direction. So what this tells me is I traveled 300 meters in the positive direction. So it tells me both of those things, and that's what change in position is. The change in position tells me 2 things. It tells me how far the object goes, and it also tells me the direction that it goes. Now, if you'll notice, there are some similarities with velocity. Velocity tells me how fast plus direction. Well, change in position tells me how far plus the direction. Now, if we take a look at the example from the data table, my final position in this case was 3 centimeters. So let me erase that. So my 3 centimeters was my final position. My initial position was 5 centimeters. And in this case, you'd end up with a negative 2 centimeters. Now, once again, it's telling me 2 things. It tells me how far, in this case, 2 centimeters, and in what direction, negative direction. Now, you'll notice in this case that we have negative 2 centimeters is my delta X, which is my change in position. If you would have accidentally flip-flopped those numbers and you would have taken 5 minus 3, then you would have gotten a positive 2 centimeters. So remember that positives and negatives have meaning in physics, and that meaning is the direction that the object travels. Now, we can do the same thing on a motion diagram. We can also do the same thing on a picture. So let me show this. Let's start with the motion diagram first. So let me make a motion diagram. I'm defining my positive direction at the end of my arrow. And I'm going to say my starting position, I don't know, I'm going to make up a number, 10 meters. And we'll say it goes pretty fast for a couple time intervals. Okay? And it is a constant velocity. I'm trying to draw those to be the same size. And let's say its ending position here is 20 meters. Okay? So real quickly, we can just fill out the chart. My starting position is 10 meters. My final position is 20 meters, so therefore my delta X, or my change in position, would be 20 meters minus 10 meters. So it would be a total of 10 meters, and then the direction that I go is positive. I know it's positive two ways. I know it's positive because the motion diagram arrows are pointing in the positive direction because I've defined that. The second reason I know that it's a positive direction is my delta x is a positive number. So that gives me how far I went plus direction. Now, if you take a look at the little picture with the cars on it, you see two pictures of cars. One of them is kind of faded. This is the faded one. The faded one represents the initial or starting position. And we just look at the front bumper. Now, if you take a look at the front bumper, you notice that that XI, or starting position, is 0, and my unit is meters because it's written out here on the chart. And then I just make sure I measure front bumper to front bumper. So this one is going to represent my final position. Now, it's a little bit darker car, and it might be a little hard to see on the video, but my XF is going to be 15, and the unit is meters. So clearly we can tell that this object is moving in a positive direction. We already know that. And so I can go through and fill out the same chart again. My XI is 0 meters. This is 15 meters. Do the subtraction, you end up with 15 meters, and it's also going in the positive direction. Just remember that the faded car represents the initial position, and the dark car represents the final position, and that's how you calculate change in position.